Dear learners, I am Dr. S. Lakshmi Manohari. I welcome you to e-learning. Today we will study about Introduction to Dyeing. You are all aware that men are fascinated by color. Color is everywhere. The clothes we wear, our surroundings are abundant with color. Color is one of the key aspects by which the consumer judges the quality of textiles. So, knowledge of dyeing is necessary for the practitioners of textiles. This module provides information about history of dye, evolution of synthetic dye, dyeing terminologies and classification of dyes. After completing this module, you will get an overview of history of dyeing, familiar with dyeing terminologies and understand the broad classification of dyes. Let's first begin with history of dyeing. Dyeing is coloring that impart beauty to clothing. It is a very old art since time immemorial. This attraction continued through the Egyptian, Greek and Roman eras and grown up to the present day. From the earliest times, man desired to color the fabrics from natural products such as brazil wood, logwood, kermes, lac insect, cochineal, Persian berries and madder. There are some evidences excavated by archaeologists which reveals that textile dyeing dated back to the Neolithic period. Ochre, a red dye from iron ore, was excavated at Catalhoic in southern Anatolia. Some of the fragments of earliest textile were kept at Museum of Anatolian Civilizations, Ankara, Turkey. It is understood that the natural dyes were used by Chinese 5000 years ago. Cotton fabrics dyed with madder were found in Mohenjo-daro, an archaeological site which is now Sindh, Pakistan. In Sanskrit, this plant name is Manjusta. It was found that saffron dyed clothes were worn by hermits. Insect dyes such as Tyrian purple and kermes and plant-based dyes such as woad, indigo and madder were key elements of commerce of Asia and Europe. Now, let us know the evolution of synthetic dyes. Efforts have been made in ancient times to extract dyes from brightly colored plants and flowers. But most attempts failed because most natural dyes are not highly stable, limited colors, crude methods of extractions. These limitations of natural dyes led to the development of synthetic dyes which dominated the market by 1900. Sir William Henry Perkin was an English chemist, discovered a new compound, morphine, which produced a purple dye while he was preparing quinine, the anti-malarial drug, at the age of 18. Perkin, who had an interest in painting, carried out further experiments with his friend and his brother. Their first experiments indicated that he dyed silk which was stable when washed or exposed to light. They sent some samples to a dye factory in Perth, Scotland and received a hopeful reply from the company. At the age of 18, Perkin filed for a patent in August 1856. At the time, all natural dyes were expensive, labor intensive, lacked fastness. The color purple, which had been a mark of royalty since ancient times, was very expensive and difficult to produce, and so Perkin and his brother realized that they had discovered a possible alternative whose production could be commercially successful. By now, you would have understood how synthetic dyes are evolved. Learners, it is very important to learn the fundamentals of dyeing. Okay, what is a dye? Dye is a natural or synthetic substance that affixes color to textiles, paper, leather and other materials. When a dye is applied to a substrate, it must be fast to washing, dry cleaning, perspiration, light and heat. Dyes are molecules which absorb and reflect light at specific wavelengths to give human eyes the sense of color. Permanence of dyes depends upon the chemical structure of the fiber and the type of dye used. There are two types of dyes. One is natural and the other one is synthetic. The natural dyes are extracted from natural substances such as plants, animals or minerals. Synthetic dyes are made in laboratories. What is a pigment? Pigments are water insoluble coloring material mostly from mineral origin and used for coloration of metal, wood, stone and textile materials. The insoluble colored particles are held on the surface of the fabric with a binding agent. The application of a dye and a pigment will be different. The dye is applied in the form of a solution, whereas the pigment is applied in the form of a paste. What is dyeing? Dyeing is the method of coloring textile materials by immersing them in a solution of a dye called liquor. The dye liquor consists of dye, water and an auxiliary. To improve the effectiveness of dyeing, heat is applied to the dye liquor. Dyeing can be done at fiber, yarn and fabric as well as garment stage. The temperature and time should be controlled during dyeing. Excellent color fastness depends upon two aspects: selection of proper dye and selection of the method for dyeing the fiber, yarn or fabric. Now, let us see the differences between pigment and dyes. The term dye and pigment are interchangeable. Both dyes and pigments are powerful colorants. The basic difference between them is that dye gets dissolved in the substrate while pigments tend to leave residues. Let us see the difference. Based on chemical characteristic, dyes are organic whereas pigments are organic as well inorganic. Based on the solubility, dyes are soluble in water whereas pigments are insoluble in water as well in most of the solvents. Based on the affinity, dye has affinity for textile material whereas pigments impart color and do not have inherent affinity. Based on the penetration of dye, dyes diffuse into the fibers whereas pigments are bonded to the surface of the fiber, fabric or yarn by other chemical agent. Based on the availability, dyes are available at large whereas pigments are available very less. Based on the product resistance, dyes has very less product resistance whereas pigments have high product resistance. What is dye affinity? Attraction between the dye and the fibers is called dye affinity. In simple terms, dye affinity is the dye absorbing capacity of textile fibers, yarn and fabrics. A number of factors are involved in this process. Example, dye liquor ratio, dye physical and chemical characteristics, dyeing auxiliaries used, time, temperature and quality of dyes. What is binder? It is a material like a gum, nearly colorless, that is used to attach a pigment. What is a mordant? It is a chemical that helps the binding of dye or dye stuff to the fibers for both fiber and dye. What is fastness? These are the properties of the dyes which indicate the tolerance of the dyes on the fibers towards the action of various foreign agencies like light, washing, heat, rubbing and perspiration. That means the dyed or printed fabric, for example, garment, curtains, fabrics, should not fade or change its color. Now, shall we go to the final content of the module, that is classification of dyes. Common classification of dyes are based on the sources from which it is taken. They could be classified as natural and synthetic dyes. Natural dyes are classified into plants, animals, minerals. The fourth one is microbes and fungus. Synthetic dyes are classified into 9 types: direct, vat, sulfur, azoic, reactive, acid, disperse, basic and modern. Now, let us learn about natural dyes. Natural dyes are dyes derived from plants, animals, minerals and microbes and fungus. The luxury dye of the ancient world was Tyrian purple. Indigo was highly prized for its color and light fastness. Kermes carmine was used as a dye and a pigment in ancient Egypt, Greece and the Near East, and is one of the oldest organic pigments. Madder has been cultivated as a dyestuff since antiquity in Central Asia and Egypt, where it was grown as early as 1500 BC. The first subclassification under natural dyes is from plants' origin. The majority of plant natural dyes are from vegetables. Different parts of plants are used to make dyes, for example, the leaves, the skins of fruit, the barks, roots or wood. Colors that are extracted from plant barks are jackfruit tree, basilwood, catechu and red sandalwood. Colors that are extracted from plant flowers are dahlia, flame of forest tree, marigold, safflower. Colors that are extracted from plant fruit are kamala, myrobalan, pomegranate. Colors that are extracted from plant leaf are eucalyptus, tamarind, tea, teak, veld, oud, babool and indigo. Colors that are extracted from plant root are dolu, madder, turmeric. Colors that are extracted from plant skins are onion. Colors that are extracted from plant stigma are saffron. The second subclassification under natural dyes is from animal origin. Insects were the main source of natural dyes of animal origin, and most of these provided red colors. The most highly prized ancient dyestuff and one concerning with much interest has always been felt was the so-called Tyrian purple. This was obtained from the juices of certain species of snails found in the water of Mediterranean Sea. The dye Tyrian purple is extracted from sea snails and shellfishes, which gives violet color. The carmine dye is from cochineal insect, which gives crimson red. The Kermes dye is from Kermes illysus, which gives red. The lac dye is extracted from Caria laca, which gives scarlet. The third subclassification under natural dyes is from mineral origin. Natural pigments are found in rocks and soils. Mineral dyes such as ochre, malachite, manganese, cinnabar, azurite, minium, argonite, ultramarine blue are extracted from different minerals which are listed in the table. The fourth subclassification under natural dyes is microbial and fungal origin. Lichens and mushrooms yields color from microbial and fungal origin. Lichens are plant-like that grow on bark, leaves, rocks, roofs and walls. They produce dyes for textiles. There are many colors of lichens that make dyes. They are a mutualistic symbiosis. The plant body consists of two quite different organisms together in an intimate association, a fungus and a microscopic green plant and algae. Lichen dyes are substantive, that means no mordant is required. Mushrooms can be used to create color dyes with a solvent. Mushroom dyes are simple to extract and yield a wide range of bright and fast colors. So far we discussed about natural dyes. The next classification is synthetic dyes. First one, direct or substantive dyes. Direct dye application is very simple, available in full color range, moderate color fastness. It has affinity for cellulosic fibers. The second one is vat dyes. These are insoluble in water and an important dye for dyeing and printing on cotton and other cellulosic fibers. These cannot be used on silk and wool. The dyeing in this case is a continuous process and is carried out in a large scale called vat. For this reason, these dyes are termed as vat. The vat dye has excellent fastness properties to washing, light, perspiration, chlorine and rubbing. The third one is sulfur dyes. Sulfur dyes are the most commonly used dyes manufactured for cotton in terms of volume. They are cheap, generally have good wash fastness and are easy to apply. They are like vat dyes, brightly colored, water insoluble and have to be converted into water soluble before application to textile materials. Sulfur dyes are predominantly used for black, brown and dark blue. Fourth one is azoic dyes. They are not ready-made dyes. These are supplied as naphthals and bases. Method of application is little complex. Comes with limited color ranges. Azoic dyes produce bright or brilliant colors such as deep reds, violet, yellows and oranges. They have excellent color fastness to washing and have good to poor light and chlorine fastness. It is suitable for cellulosic fibers. Fifth one is reactive dye. These dyes are soluble in water. There are two types of reactive dyes, hot and cold method. Cold dyeing is used in batik printing. It is not suitable for synthetics. It has excellent fastness to laundering, caulking and dry cleaning. The sixth one is acid dye. It is commonly used for silk, wool, nylon and modified acrylics. It has no affinity for cotton cellulosis. Acid dyes are water soluble and have better light fastness than basic dyes. Seventh one is disperse. Disperse dyes are water insoluble dyes that dye synthetic polyester and acetate fibers and sometimes nylon and acrylic fibers. These are non-ionic dyes having low molecular weight. It dissolves in organic solvents. There is a uniform dyeing but limited to pale shades. It requires skill in application of dye because the dyeing has to be carried out at a high temperature. Eighth one is basic dye. The most brilliant dyes among all synthetic dyes are found in this class of dyes. However, they have poor light fastness. They fade in sunlight quickly. Basic dyes have direct affinity for wool and silk but not on unmordanted cotton. For dyeing cotton, the basic dyes require mordant such as tannic acid or some synthetic organic substances. The ninth one is modern dyes. Before the development of synthetic dyes, it was found that dyeing of wool becomes wash fast with addition of some metallic salts. These salts were named as mordants. The word mordant is derived from the French word mordre, which means to bite. A mordant is an acidic or basic salt of chromium, iron, aluminum or tin which helps through penetration of color into fabrics. The dye that has affinity for one type of fiber may not have affinity for another type of fibers. This problem can be overcome by the use of mordants. There are three methods of modern dyeing, namely chrome method, metachrome method and after chrome method. Other important dyes. A number of other classes have also been established based among others on application that includes the following. Leather dyes. Leather dyes are usually azo-aniline group dye that fix firmly to the leather. Optical brighteners. It is used for textile fibers and paper. They are fluorescent whitening agents that are colorless to weakly colored organic compounds. It was discovered in 1929 by P. Crace. The whiteness of viscose rayon and the semi-bleached flax yarn was increased by treatment with an aqueous solution of esquilin and drying. Esquilin was obtained by extracting horse chestnut bark. Fluorescent dyes. A very innovative dye. Fluorescent dyes have the important property of absorbing in the UV range and emanating in the visible range of the color spectrum. The main use of fluorescent dye is in the coloration of synthetic fibers like polyester, polyamide and acrylics, especially for sportswear use. Sublimation dyes. It is used in digital printing that gives strong light fastness characteristics. The dyes can potentially be used to print textiles for commercial, architectural or outdoor application. Let us conclude that dyeing is the craft of imparting colors to textiles by treatment with a dye. Throughout history, people have dyed their textiles using natural dyes. Plant-based dyes such as woad, indigo, saffron and madder were raised commercially and were important trade goods in the economies of Asia and Europe. In 1856, the whole art and dyeing was completely revolutionized by the discovery of the artificial dye stuff named mauveine. The discovery of synthetic dyes superseded natural dyes for the commercial textile production. Still, natural dyeing techniques are preserved by artisans in traditional cultures around the world. Thank you, learners, for listening. I hope you have good idea about history of dyeing, terminologies of dyeing and classification of dyes.